Okay, so the topic we are going to talk about today is web security. So historically, the web was just a request response protocol, which means that basically the clients request a web page and the server returns the contents of the web page. Okay, so it was largely passive when the web started, and because of this nature where the client makes a request and the server immediately responds, HTTP was designed to be a stateless protocol because when a protocol is stateless, that means the server can crash and the client can crash and they can just come back without having to remember any of the state. This means that these crashes don't matter, right? So let's say you make a request to a server and the server crashes while it's processing the request. It doesn't have to remember anything. It comes back up, you send the request again, and it's as good as the server never crashed. The same thing happens if the server sends a response and the client has crashed. Again, the server doesn't have to do anything special. It doesn't have to remember that it was serving this request and try to send back, retransmit that or anything like that. And as such, the HTTP was designed to be stateless because it gives this kind of failure resilience. And so, and again, in the early days, it was envisioned as a way for exchanging information, right? So people, primarily you have passive web pages, people post information on those web pages and they link together different documents so that it is easy to navigate. So that's what web was originally designed for, right? But currently, of course, web is anything but passive, right? So there are very few passive web pages that we see anymore. Even pages that we tend to view as, essentially information content often is dynamic and interactive and whatnot. So because of this, in order to be dynamic and interactive, this means that the web pages have to be stateful, right? There has to be some, there's a lot of personalization of content, which means that the server has to maintain state as to who's the user that's visiting that page. There are transactions that go on, like when you do e-commerce, and then you have to remember exactly what state of the transaction you are in. And that again requires a state to be maintained. And so there is, you no longer have this, passive, web pages that you're dealing with. So the result is that the computation is distributed because some of the computation happens on the server side, some of it happens on the client side on your browser. And this also means that the trust model is distributed because there are some things that happen on the client side, you have to trust the client, some things that happen on the server side, and you have to trust the server, right? So how does it work underneath? So you have this HTTP requests, right? So a client sends a HTTP request to the server in order to request a page. And the HTTP protocol has a number of fields. One of the fields is called a method, right? So what is the request that is being made? And the method has certain parameters. And then there are a bunch of headers, which you can think of as some additional parameters that are being provided. And then there could be a body of the request, okay? And HTTP itself supports a number of methods, but the ones that matter in practice are get and post, right? So get is intended for information retrieval. So in good old days, get would mean, you specify some web page, which is this path to resource, and that's it. But as the web became interactive, where each request ended up looking more like a function call, there were a bunch of parameters that you could provide, and these are provided as part of the query string. And so a GET request typically contains a URL, which consists of the resource location plus a bunch of parameters. So now there is also the POST request, which is used for submitting information, right? So in a GET request, the only information that the client submits is basically the parameters or the query string. Whereas in a POST, there might be much more information that is transmitted. So for instance, if you, let's say, go to a website where you are, let's say, editing a document, then when you finish and save a document, then that might be sent as a POST request. So originally, POST was intended to for sending large amounts of information back to the server, whereas a GET was intended as something where the primary thing is just the page that you are trying to access. So So if you look at the details structure of a GET request, right? So a GET request, looks like this, right? So if you look at the data that is being transmitted at the network layer, this is what you would see. You would see a header in the response. Okay, I'm sorry. So let's go back to what the client sends. The client will send, something like this, right? So here is the name of the request. Here is the particular resource that you are trying to access. In this case, there are no parameters, so there is nothing, there is no question mark, and there is nothing else that follows the name of the file or the name of the page. And then this part basically says what is the protocol version, okay? And when the server gets this, the server, responds to the request. And what it does is basically it sends a header, and then it sends the content over here. Okay, so the header contains a number of fields like the response code, the date, server information, and content length, and content type, and so on. So again, the structure of a GET request is shown here, which and we have seen it many times. So again, after this question mark is a set of parameters. So this is the parameter name, and this is the parameter value, and the ampersand is used to separate multiple parameters. So here there are two parameters, session ID and pay. Okay, and session ID has this value, and parameter pay has this value. Okay, and you can see that in a GET request, any user input is sent as a parameter to the GET operation. So in a POST request, so POST is commonly used when you submit a form. So most of you are familiar with pages where there is some kind of form that you need to fill up. And then when you submit, then sometimes the form submission uses a GET request, but generally it is recommended that you use that web pages use POST in order to submit. So the difference is that in a GET request, the URL itself contains the parameters, right? So this means that it is easy to create a bookmark or a link that includes the information about not only the page, but also all of the parameters. Whereas in the case of a POST request, the information is going to be sent in the body of the request. So there is no way to sort of bookmark a POST request. So so this sort of works in both ways. So while GET requests are more convenient in terms of bookmarking and so on, they are also convenient for attackers because they can send you a link with malicious parameters in an email. And if you click on that email, then basically you end up submitting a request with these malicious parameters. So the attacker has tricked you into submitting this malicious request. So so GET requests are easy to abuse that way, whereas POST requests are harder to abuse. Okay, so in particular, if an attacker wants to trick you into submitting a malicious POST request, then the only way for them to do that is if you are already on their web page. When you are on their web page, then that web page, either when you click or when some JavaScript on the page executes, it can send out a malicious POST request, right? So, but as a general rule, if the attacker is trying to phish you, then it's difficult to directly, send you to a page with malicious parameters using POST requests. So what they end up doing is that they often phish you and send you to an attacker control page. And from that point on, well, they can do anything. So HTTP response, we already saw the example, right? So there is a status code and there's a status message. There is a bunch of headers and then there is a body, okay? So the response codes, they all based on the leading digit. You can loosely identify what the error or lack of error is. So if it starts with a 2, that means the request was successful. 3 means the request was redirected, meaning maybe the server is sending you to a different web page. Client-side error means there was some kind of error on the request, and so it could not be serviced. And then 5xx means a server-side error, which means that there was an error while carrying out the request on the server side. Okay, so this is an example of a full HTTP response. You can see the information such as the 200 OK, which says the request was successful. It tells information about the server. It tells you, information about the page, such as when it was last modified. It tells you what is the length of the content. So this allows the client to know when they have received all of the page, right? So they can wait for this many bytes, and when they have received that many bytes, then the client knows, well, they have received the entire page. And then the content type tells them, okay, exactly what is the type of the content. And very often the content is text/HTML, which is the HTML page that we typically get. And then the actual content of the HTML page starts, okay? So any questions so far? So I said that the content length is useful for the client to figure out when the request is complete. Uh, why can't the client know that the request is complete when the connection is closed? Anybody wants to answer that question?
The connection can be closed due to a variety of reasons, like internet failure or different sort of
Okay,
thing.
that's a good answer, but there is an even better answer.
Did he mention just disconnecting from the internet?
I'm sorry?
I couldn't hear his answer. Did he mention disconnecting from the internet? Just
Right. So basically, he was talking about, the content getting truncated because of some error. So any other reason?
We can only, Professor, we can only like have certain length of like body in a given packet. So maybe.
So again, you should not, HTTP runs on top of TCP, right?
Okay.
So TCP has no such thing.
Okay.
No limit, right? So again, so one of the things when you try to learn about security or anything in systems is that you need to sort of put together what you learn from many different courses into one, right? And so what you learn from networks class in terms of, protocols and layering and whatnot is something that you need to sort of bring forth here because that will, without bringing that here, some things won't make sense. So anyway, another reason is because in the early days, HTTP 1.0 protocol, the way it worked was that you will establish a separate TCP connection for each HTTP request. So when the server closes the connection, you kind of know that the server is done. But the HTTP 1.1 protocol, what it does is the connections are persistent. So if the server and client, if the client makes multiple requests to the server, then all of them can use the same connection. So so for that reason, the connection cannot really be closed. Okay, so that's so when the connection cannot be closed, then having some information like the content length helps you figure out when the data from the server is done. So cookies. So
Professor, I had a question.
yeah.
Yeah. So is this HTTP response two-way? For example, if we submit a form via a GET request, will a response also be sent, or only it's one way, like from the server to the client, or it goes both ways?
I don't understand what it means for the response to go both ways, because the word response says, it's a reply to the request. So a request comes from the client to the server and the response comes from the server to the client.
So if we are submitting a form, in that case, there is something going from the client to the server, right?
Right. That is a post, typically a post request, but sometimes it can be a GET request when you submit a form.
So in that case, yeah. So when we submit a form, would a HTTP response go from client to server, or it's?
So again, here the word request means it is something initiated by the client. So it is a message sent by the client to the server. The word response means it's a message sent by the server to the client.
Okay.
Okay.
So I was just wondering how the body, like you said that when we send a post request, the parameters go in the body. So
correct.
like,
so the request has a body.
Does it look the same way, the response which we saw on the earlier page? Does it look like that only, or like how does the body look?
At a high level, it'll look kind of similar, yes. Okay, so if you look it up, you will see that the specifics. I don't recall whether it's exactly like the way the response from the server looks, or somehow the structure is a little bit different.
Okay.
But conceptually, it's basically the same.
Okay, thank you.
Okay, so we said that when the web started, everything was sessionless, stateless. And so, but now there is a lot of state that needs to be maintained. And therefore, we need a mechanism for, remembering state. And that's where cookies come about. Okay. So, so the way cookies work is that cookies are set by the server. Okay. So when the server sends a response, they can include a set cookie header, which identifies the cookie name and cookie value, right? So the protocol itself doesn't say, what the cookie names can be. They can be arbitrary strings, and cookie values are also arbitrary strings. Okay. So the way this works is that when the server sends the cookie, the browser remembers the cookie from that point on. And in every subsequent request to the same server, the browser is going to send back that cookie. Okay. So this way, there is some persistent piece of information that is sent back and forth. And this can be used to maintain state between the server and the client. Okay. So, so the subsequent GET request from the client, or it can be a POST request as well, the specific cookie that the server sent is being sent back, right? A server can set, any number of cookies, and the client will remember all of them, and the client will send all of them back to the server. Okay, with each request, each subsequent request it makes to the server. Okay, so if you think about a session where the server is remembering, maintaining state, such as what is the user, maybe the server has information about the user's credit card or home address or things like that, and it can look up all of that information using this session ID. So what the server does is that it creates some kind of a key that with which it can look up, client information, and then it sends this identifier or handle or whatever you want to call it back to the client. And each time the client submits a request, the client is going to provide that handle using which the server can look up user information. And this means that the server doesn't have to ask the user for this type of information again and again, right? If you are asked for information every time, then of course you are you can't really use the web at all. So cookies are used for many purposes. Authentication is one. So when you log in to a website, once the website has authenticated you, it's going to store some information on the server side, identifying who the user is and any other information such as the time you logged in and so on. And then it's going to create what is typically called a session ID, a session cookie, and the session cookie is going to be sent as a cookie, and so for the duration of your login, this session cookie is going to be used to maintain the your credentials on the server side. So cookies can also be used for personalization because, well, if once you authenticate, if it's going to be able to look up your personal information or your preferences on the server side, then that could be used as that's one way of using the session cookie itself for personalization. But other times what happens is that you may make some preference choices on a web page, and these preferences can be packaged up into a separate cookie that is set by the server, so that this kind of personalization choices can be carried around for all subsequent requests from the client. And more problematic is tracking, which many of you are probably aware of. How when you go to one website and you look up some information, and then you go to a different website, somehow, you might see suddenly, there are advertisements that pop up that seem to relate to, the thing that you looked up on the other side. And this is happening because of what is called tracking. And tracking can, maintains information about your requests, and sometimes across different websites and so on. And this is also done using cookies. So one of the things that we said is that cookies can be used to maintain sessions. And if you have multiple users, each user logged in on the website will have a separate session. The session IDs have to be unique for each user. And so just using this session cookie, the website can figure out who is on the site. Okay, and notice that it doesn't, websites generally don't care about your IP address. It is really, they are really caring about the session cookie in order to figure out who they are talking to. Okay, so there is a good reason why they don't use IP address. Can anybody tell me why IP addresses are not a good indicator of, not a good way to associate, which user is, currently talking to the server?
They could be using VPNs and changing their IPs.
Okay, so why does the use of VPN matter?
Because their IPs will keep on changing if they are using a VPN.
No, if you use a VPN, you have, the only thing that happens with a VPN is that you may be in one place, but you have an IP address that might correspond to the network of your organization. And the server would see an IP address from your organization, but that doesn't, really affect anything.
Yeah, but like VPNs give us the option to like change IPs from any country. So it might be possible that user keeps on changing, but that's a possibility. Not.
Yeah, but there are sort of more benign, you don't have to work so hard to do this.
ISPs could
Right,
change.
so people, move from place to place, which often means their IP addresses change, right? So, so that means that so obviously you don't want to lose your session just because your IP address changed. So that's one reason why it's not a good idea to use IP address. And there is another reason which should be, be the very first one that should have come up in your mind.
Is it multiple people on the same work can access the same site and they'll have the same outgoing IP address?
Right. So most of us sit behind what are called NAT boxes, right? Network address translation. So if you are at home and you're using multiple devices at home, then what your wireless router or cable modem is doing is it's, the cable modem may have one IP address, and but you may have multiple users at home, each of them having a different session with a server. And as far as the server is concerned, you're all coming from the same IP address, because the only IP address it sees is the IP address of your cable modem. Okay, and there is a trick called network address translation that the cable modem uses in order to allow all of these devices to, these devices that you have, multiple laptops and phones and so on, each of them have their own IP address, but these are what are called private IP addresses that are not visible to the server, right? So somehow using this NAT magic, the cable modem is able to route the packets from each of these devices to the server, and but the server always sees all of these coming from the same IP address, which is the IP address of the NAT box. So for that reason, IP addresses are not that good to, not a good way to tell whether, it's the same user, because the same user may end up having multiple IP addresses because they move around. And it's also possible for multiple users to have the same IP address. Okay, so that's why cookies are being used. But what that means is that if the user deletes the cookie, then the server is no longer able to retrieve the information about the user on their side. And so if you are concerned about tracking and so on, deleting cookies kind of helps, because the server is no longer able to correlate your activities based on your cookies. Okay, but again, when we are talking about tracking, you should keep in mind that while cookies are the most obvious and explicit way to do tracking, websites have gotten very good at tracking you even if you disable all cookies. And so, just deleting the cookies is no longer going to be enough to prevent tracking. So you have to go beyond that. But it is true that if you delete the cookies, then you make it much harder for websites to track you. So session identifiers are, as we said, typically they are used when you go into a website and you log in. And at the time of login, it creates information related to your session, it stores it typically in a database, and this information can be looked up using a random string. This is, incorrect. It should not be pseudo-random, because pseudo-random suggests it's not cryptographically random. It should be generally cryptographically random, because the client should not be able to figure out how to create a session ID with a certain value. Because if you recall how these cookies work, the server sets the cookie and then sends it back to the client, and the client then is supposed to send back the same cookie back to the server, but the server does not know and does not have a way to check whether the cookie being sent back by the client is one that the server set in the first place, right? Because a malicious client can, make up any cookie and then send it back to the server saying that this is the cookie you sent. So if the client can guess this session ID, then the client can, basically forge a session or masquerade as some other user. And that's why these session IDs have to be cryptographically secure, right? And again, because these session identifiers are a handle to look up and use any user-specific information on the server side, they are as sensitive as the username and login that you use, with just one limitation, which is that where your username and password are good for any number of sessions, but a session ID is useful only for one session. So if you log out, then the session cookie is no longer useful. Somebody cannot steal your session cookie and reuse it once you log out. In addition, the session cookies often have a timeout period, after which they become useless. But if somebody manages to steal your session cookie before it expires, then they can masquerade as you, and they can do anything that you can do, right? So that's why it is really sensitive. Any questions on this? Okay, so far we've been talking about the server side and maintaining state between the server and the client. But so far, we have only seen action on the server side, and we haven't seen much action on the client side, right? So we have only talked about sort of things like clicking, which means a passive web page. But really, today, the web is full of active sites where the web page is interactive and dynamic and personalized and whatnot. And this cannot be done with static HTML, right? So you need pages to be dynamic, which means that they must have some code running on the web page. And this code is, JavaScript, right? So that is pretty much the only language that is supported by browsers is JavaScript. So these JavaScript scripts can be included in web pages, and when a client fetches a page and displays the content, if the content includes JavaScript, then the browser starts executing this JavaScript automatically, right? And the scripts can be embedded in the page in such a way that they can run even before the HTML is loaded, or during the time you are viewing the page, or after some time after the page is loaded, or when you leave the page and navigate away from the page to go to a different website, and all of that. So the most important thing we need to remember is that JavaScript provides a mechanism for random websites to execute code on your machine, right? Because I say random because we don't think too much before navigating to some website, right? So we don't say, hey, visiting this website could be dangerous. While it is true that there are some web pages that are truly dangerous, we generally tend to think that the danger posed by any random website is minimal. But this is because we often tend to have this view of a static web page. Because if you think about the fact that the page is dynamic, then we should realize that many web pages could be dangerous to visit. And in fact, many browsers today keep track of, have a mechanism for keeping track of websites that are known to be malicious, and they warn you before you visit those pages. But that aside, the reason why you need to be mindful of visiting web pages is because anytime you visit a web page, that web page can send you content which includes code, which is in JavaScript. And so executing code, that means, so we often talk about threat models, and we have said that if somebody is only able to send you, if an attacker is only able to send you some data, then the attacker's capabilities are relatively weak. Whereas if the attacker can send you code, then the attacker is essentially a much stronger adversary. And so with the web, because of JavaScript, we have a relatively strong adversary. And so we need to be careful about that. So JavaScript, came about in the early 90s. And since the name Java was very popular at the time, people decided that we should, call this language, we should have some Java in the name. And so, you can see this quote, which is a nice quote. Java and JavaScript are as related as car and carpets are related, right? It's a funny quote, but at the same time, it's not quite accurate because Java and JavaScript do have some relation, and that relation is that they are both safe languages. Okay, and we'll talk about that briefly. But let's, say something about Java and Java security, because when Java came out, one of the things people thought was that, hey, Java is a safe language. This allows, web pages to be dynamic because you can have Java code as part of web pages, and then Java code can execute. And because it's a safe language, you can make sure that the risks are minimal. But as it turned out, a series of papers came out in the late 90s that showed that even this safe language, and even with all of the security mechanisms that were built into JavaScript, that were built into Java, it was easy to find vulnerabilities in the Java virtual machine and the access control policies, which made it possible to carry out attacks. And so there was a lot of bad press, and people very quickly stopped using Java for on the web. In parallel, JavaScript was developing, and JavaScript had a different philosophy. So while it was, it followed Java in the sense that it was a safe language. You don't have, like binary code. You don't have low-level issues such as buffer overflows or memory safety issues. And these get rid of a class of problems that we have when we are able to send and execute binary code. So in contrast, when we deal with languages, safe languages, then these low-level problems, we no longer have to worry about. So, so that is good in that sense, but it turned out that the policies that need to be enforced weren't, very obvious in the case of Java, and it was too easy to misconfigure and allow the malicious websites access to your computer that you didn't really want to provide that kind of access. So JavaScript, so again, Java didn't do certain things right. In particular, Java's model was, Java didn't think of that it was interacting with the browser, but the idea was that you were interacting with the underlying operating system. So it had policies for saying, can this applet access the files on the system? Can it read the files? Can it write the files, and so on? And this is really not the right level to think about, websites and so on. And so what JavaScript did is they started with, the most important point is that the browser is the platform, not the operating system. And this is really the key for JavaScript, and is the reason why JavaScript became popular, because once you realize that browser is the platform, then integration with this browser and providing access to the browser in a controlled way, that becomes the focus of the language, right? So true, it is going to, it's a language. Safety is still the basis for security of JavaScript, okay? But that is being used not to provide an interface to the operating system, but to provide a safe interface to the browser, okay? And the other thing that they did is that the JavaScript itself is an object-oriented language, and they developed an object-oriented security model that was much easier to understand and use. And and again, because it is about how you integrate with the browser, it doesn't even ask questions like, is this web page allowed to access, local files? Because there is almost no website that should be able to access your local files without your explicit consent. And so instead of asking or using policies that say whether a website can access your files, it instead, the notion here is that if any website can access your files, provided the website gets explicit consent from the user, and this consent is given through the browser. So a browser has sort of a trusted dialogue that pops up whenever a website wants to access your files. And then if you say yes, then the website is able to look at your files. Again, a lot of the development of the HTTP protocol and things like cookies and sessions and whatnot, they evolved in conjunction with JavaScript, and JavaScript was, went through many quick revisions in order to, keep up with all of these changes. And so the net result was that JavaScript was, really, conducive to, writing dynamic web pages that are easy to use, that are responsive, that provide the kind of functionality that users need, and so on. Okay, so let us stop here, and we'll continue, whenever. So either I'll record more of the lecture for you to look at offline, or we'll meet the next time. Okay, so very good. Any questions on what we have covered so far? Okay, if not, let's stop here. And
Excuse me, I actually have a general question.
yeah.
It seems like you combine these meetings that we have in person and the stuff that you post solely on the YouTube channel. Is
Right.
there a way for you guys to distinguish what we have already covered in class from what's extra? Well, not extra, but just the extension of what we've done here. That way we can determine where to start the watching. Okay.
Good point. So I'll make that. That's
maybe it's just like a little dashed line in between.
Right. Yeah, good suggestion. We'll figure out a way to do that.
Thank you.
Any other comment, questions?
Professor, in
Yeah.
case of scraping, for example, if there is any bot or any fake browser which is trying to access any website, and some kind of authorization token is passed in the URL for the scraping to access the signed in pages, then in that case also trusted dialogues will be popped for the user to give explicit authorization or not?
So I'm not sure I follow the question, because typically if you talk about scraping, then scraping is often done by scripts, and the user is not sitting in front of a browser and doing the scraping.
But if a scraper is trying to access a page which belongs to a particular user, and that requires some kind of signed in, and the user is already signed in on, say, Google Chrome or something, and by default the scraper is taking the authorization token and
Right.
Sort of trying to access the signed in page, then
Right.
in that case I'm trying to understand whether the browser will pop up some kind of trusted dialogue for the user to understand that some kind of scraping is being done illegally or not.
Well, okay, there is nothing illegal about it, but something like this cannot be done using a JavaScript running on the page, because any JavaScript that's running on the page is something that the server sent, right? So the only way the user can change and inject something into that page is if the user, is using some kind of an extension to the browser, and these extensions are often not, they have, they can do pretty much anything, and these extensions can then do the scraping. So in those cases, right, so these extensions can have, more privilege, and depending upon the particular framework or environment these extensions are using, they may have full access on the user's machine. But again, as you see, this is an extension that the user installed. So it's reasonable for this user installed extension to, access the system, because what we want to make sure is that the server should not be able to access things on the user side without user permission.
Okay.
Very good. So let's talk again next Monday.
Professor,
Yeah.
I had one question.
Yeah.
Regarding in the topics of cookies, there was about you talked about tracking.
Yeah.
So in that, you said so as far as I know, the one website cannot read the cookies of the other website. So in that case, how can one they can track us, because they can only read
So
the
we'll
data.
talk about this in the next lecture, because when we talk more about the same origin policy and so on, right? So
Okay,
bring up the question in a future class when
Sure.
we have understood these things.
Sure, Professor. Thank you.
Anything else? Again, feel free to, we are 5 minutes past the class. If anybody has a question, I'll answer it, but the rest of you feel free to drop out. Don't have to stay on just because somebody has a question. Okay, very good. I'll see you next Monday.